Modern large language models are built to ingest and synthesize millions of unstructured data points in mere milliseconds, operating at a completely frictionless speed. But that frictionless speed hits a wall the moment it meets modern regulatory frameworks. For decades, corporate compliance relied on static policies. Legal teams reviewed operations through manual spreadsheets, updating them maybe once a quarter. Generative AI breaks that model completely. The outputs are too dynamic, and the iteration cycles are too fast for human review to keep up. The solution is a discipline called AI GovOps, AI Governance Operations. It takes legal compliance out of the spreadsheet and drops it directly into the DevOps engineering cycle. This means embedding programmable guardrails and real-time risk scoring straight into the system's architecture. Surviving the rigors of AI regulation requires engineers who can translate rigid legal text into automated code within a CI/CD pipeline. The EU AI Act establishes the baseline for these global requirements. It is the world's first comprehensive, enforceable AI regulation. This chart shows the core operational mechanic of the Act, a four-tiered risk hierarchy. Every AI system deployed in the EU falls into one of these categories. At the absolute top are prohibited systems, including social scoring and real-time remote biometric surveillance, which face an outright ban. Directly below is the high-risk tier, the primary battleground for AI engineers and compliance officers today. Minimal risk systems usually require nothing more than a basic transparency notice. High-risk systems introduce intense, heavy operational friction. Falling into the high-risk category triggers mandates for quality management systems, continuous auditing, and exposes providers to multi-million-dollar penalties for noncompliance. Correctly identifying whether a system crosses that high-risk threshold dictates the technical requirements and legal liability for the entire product lifecycle. Article 6 of the Act sets the broad legal definitions for risk, but the exact, exhaustive list of high-risk triggers lives in a section called Annex 3. Annex 3 is designed to capture AI systems that have a significant potential to harm human health, safety, or fundamental rights. The text outlines 8 critical areas. If your AI touches any of these domains, you are operating in high-risk territory. The first cluster includes biometrics and law enforcement. State-level surveillance and predictive policing tools carry inherent risks to civil liberties. The next cluster covers societal infrastructure. This captures systems managing vital public resources, processing visas, or assisting judicial authorities. The final cluster is where most private corporations get caught: employment, education, and essential private and public services. To put that in perspective, an AI powering video games for minors is minimal risk, but an algorithm screening resumes to decide who gets a job interview is firmly high risk. Fast-moving tech companies often build systems targeting these corporate categories without realizing they've crossed a strict legal line. Annex 3 provides the specific architectural boundaries that mandate how an AI system is built. Consider a fast-moving fintech startup deploying a proprietary large language model. This system ingests unstructured alternative data, like social media and spending habits, into a central black box LLM to output a credit score. That standard setup immediately triggers a legal tripwire under the EU AI Act. It maps directly to Annex 3, Point 5b. Under Point 5b, using AI to evaluate creditworthiness or establish credit scores is legally classified as a high-risk activity. Because of this classification, the startup's current opaque black box model is functionally illegal to operate within the European Union. Regulators demand total explainability, proactive bias mitigation, and guaranteed human oversight. The startup faces a binary choice: abandon the lucrative European market entirely or completely re-architect their data pipeline to hard-code compliance. To comply, the engineering team must break open the black box and integrate specific compliance nodes directly into the data pipeline. The first mandate is implementing a quality management system, or QMS. In practice, a QMS integrates automated risk scoring and continuous testing directly into the CI/CD pipeline, catching errors before deployment. The second mandate requires automatic logging and record keeping. Automated data lineage becomes necessary because auditors must be able to trace exactly which piece of alternative data influenced a specific credit score months after the fact. The third mandate introduces programmable guardrails, like NeMo or LlamaGuard, wrapping the core model. These guardrails provide real-time drift and bias detection. They instantly flag and block the model if it begins outputting discriminatory credit scores. The final mandate is human-in-the-loop oversight. This acts as a manual gatekeeper before the AI's decision reaches the customer. By mapping these technical nodes to the requirements, the legal text is translated into a functional AI GovOps architecture. The fintech system now runs flawlessly, generating audit-ready artifacts without requiring manual intervention. This continuous automated dashboard replaces the slow, manual legal spreadsheets that used to define corporate compliance. Identifying an Annex 3 trigger informs the design, but long-term resilience requires executing continuous AI GovOps. This rigorous intersection of legal risk assessment and DevOps automation forms the core competency of the IAAP AIGP standard. While this architecture satisfies the requirements of the EU AI Act, it also universally prepares a system for emerging global regulations from the United States and expanding to Brazil. Compliance operates as a technical moat. Companies that build compliant foundation models will ship faster and operate more safely than their competitors. Mastering AI GovOps is the strict requirement for shipping resilient, trustworthy, and globally scalable AI systems today.